Hello all. So as a continuation of my lecture series of special electrical machines, now we are discussing about the controllers which is used in the permanent magnet synchronous machines, which is used to control the speed of the motor. So here now next type is we are going to discuss about self-control technique, where we have three types: vector control, self-control and microprocessor, and this video deals with the self-control technique. The self-control it is going to correct by its own self. So as the rotor speed changes, the armature supply frequency is also changed proportionally so that the armature field always moves at the same speed as the rotor. The armature and rotor field move in synchronism for all the operating points. This is a very important point. And here accurate tracking of speed by frequency is realized with the help of rotor position sensor. When the rotor makes a certain predetermined angle, the axis of armature faces the firing pulses. To convert feeding the motor, it also change. The switches are fired at a frequency proportional to the motor speed, and hence the frequency of the voltage induced in the armature is proportional to the speed. So this is how we are going to maintain the speed at a constant value. This self-control ensures that for all operating points, the armature and the rotor field move exactly at the same speed. And the torque angle is adjusted electronically, hence there is an additional controllable parameter passing greater control of the motor behavior by changing the firing of the semiconductor switches of an inverter. And this torque, hence the fundamental component of A needs, and it lies along the direct axis that rotates at the synchronous speed. And this is achieved only by the direct axis and behind the axis A. Coming to the diagram, so here we have a motor. In this self-control, we are going to measure three parameters. One is voltage, another one is speed, and using this speed, we are going to control the current. We are not going to measure the current, we are going to control the current. So here we have a terminal voltage sensor in which the voltage from the value of voltage, the frequency is given to the phase delay unit, and where the firing circuit can be firing angle can be corrected, which is given to the converter. We have two converters here. One is load side, another one is input side, which is also called as source side converter, and the AC supply is given. So measure the voltage frequency. That frequency is given to correct the firing angle, and with the help of that, the particular motor can be controlled with the speed. And another thing is, using RPS, we are going to measure the speed controller, and we use current limiter unit, and current limiter unit will give the output to the current controller, and whereas it is given to the converter, so that the switching keep on changing, and this process continues in order to control the speed of the motor. So here we have main 5 parameters like source converter, load side converter, voltage controller, voltage sensor, and speed controller and current controller unit. So it is going to correct the speed by its own self by changing the voltage and frequency of the circuit. So this is how the self-control technique works. So coming to the assessment, in this case of a 3-phase induction motor, plugging is done by starting the motor on load which is more than the rated load, pulling the motor directly online without a starter, interchanging connections of any two phases of the stator for quick stopping, or looking of the rotor due to harmonics. So the answer is interchanging connections of any two phases of the stator for quick stopping. So in case of a 3-phase induction motor, plugging is done by interchanging the connections of any two phases. If the terminal voltage of the induction motor is decreased, then current will be decreased. The terminal voltage of the induction motor is decreased, then current will be decreased. A 3-phase induction motor is essentially a constant speed motor. So this 3-phase induction motor is essentially a constant speed motor. So in this video, we have discussed about another control method to control the speed of the permanent magnet synchronous machine, which is self-control synchronous machine. In this, we are going to take two parameters. One is voltage, which is used using voltage sensor, and another one is speed, which is measured using RPS. And this measured voltage is given to the phase delay unit, whereas in the firing circuit the angle will be changed and given as input to the converter. load side converter, and whereas the speed it is given to the current limiter unit, and the current controller will give to the source side converter, and so that the process continues in order to maintain the speed at a constant value. Thank you.